Hello students, welcome to this lecture in which we're going to talk about multiplication cipher. So last time we learned a little bit of algebra to help us to create the cipher that is better than scissor cipher, which is a shift cipher. And this one is a multiplication cipher, and a lot of people call it decimation cipher. Decimation cipher. So if you see word decimation cipher, that means multiplication. So what we're gonna do, we're gonna encode with k with key equals to k, and we will multiply the numeric value p of a letter by the number k. Instead of adding like we did before with scissor cipher, we added the key, but now we're gonna multiply by the key, and we're gonna use mod 26 to wrap everything back up to the beginning of the line. That's our idea. I copied the alphabet here because it takes a while to write it out. And mathematically, that's what we're going to do. Mathematically, we're going to take letter P, multiply by K, and we're going to do mod 26. That's relatively simple, very much the same as before, but instead of sum, instead of a plus, we have a product here. So let's do an example to see how it works in practice. Again, it's not much different from the addition. So the assignment says encode letter team, encode letter word team using decimation cipher, with k equals 7, with k equals to 7. So we already have the alphabet, we don't have to write it up, and we just start with letter T. So we go to the alphabet, we look up T. T has a numeric value of 19, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? So position 19 equals to value 20 in the position because we start counting from 0. So 19. So we take 19 for T, and as the rule says, we multiply it by K, so it's 19 times our K is 7, so we multiply by 7, and we do mod 26. So let's see what we're going to get. We will need our calculator, so our calculator is 19 times 7, we get 133. 133 mod 26. So we're going to use a calculator to do that. We'll divide 133 by 26. We're going to get 5.11. So that means 26 goes 5 times into 133. For us to find the remainder R, we need to take 133 and subtract 26 times 5. So that's what we're going to do. All right, so 133 minus 26 times 5. So we're going to get number 3. So that means this is 3. And since this is 3, we'll look up number 3, position 3 in the alphabet. That's going to be letter D. Again, our position starts at 0 because we don't want the end at 26 because it will be a little bit ambiguous since our mod is 26. So we're done with T. We go to letter E, and letter E has number 4. That means 4 times 7 mod 26. So 4 times 7 is 28 mod 26, and when the numbers are close to each other, we can just subtract 28 to 26, because if we would use long division, 28 by 26, this would be 1, and we would subtract 26 to get 2. So when the numbers are small, it's easy to calculate in your head. So we get number 2, and we look it up in the alphabet. It's C. Next letter that we need to deal with is A, but apparently A is really easy to deal with because it has a position 0, and 0 times anything is 0. Conclusion, A doesn't move anywhere because we get 0 mod 26, but since 0 is smaller than 26, it's just 0, so we get A back. So unfortunately, this cipher doesn't move A, right? So there's some drawback in this cipher. Last letter that we need to deal with is letter M. M, what position is M? M is 12. So we take 12, we multiply 12 by 26. We do modular arithmetic to wrap everything up. 12 times 26, 312. 312 mod 26. Again, we're going to use calculator to do that. So we take 312 and divide by 26. So it's mistake, right? Mistake. Made 2 mistakes, right? I have to multiply. There is something went wrong here. Something went wrong. Let me fix it. So I multiply by 26, but this is 7. The key is 7. I have to multiply by 7, not by the number of letters in the alphabet. Still get 0, still get 0, still get A. This is fine, but this one is wrong. So let me fix it. 12 times 7 is 84. 84 mod 26. So it's 84 divided by 26. It's easy to get confused here, so be extra careful. So what does it mean? 3 times 26 goes into 84. So it's 84 minus 3 times 26. 84 minus 3 times 26. So we get 6. So that means this is 6, and if we look it up, 6 is G. 6 is G. So that means if we take word team and encode it with multiplication cipher, we're going to get DCAG. DCAG. So that means it's relatively simple to use this code, but it has some drawbacks, like letter A does not move. Easy to make mistakes. Be careful. You have to multiply by the key. But there is another very, very important drawback. Let's look at this example to understand what could go wrong. So, strange result. Strange result. Exclamation point, maybe not that. So what could go wrong? Suppose we're going to take our alphabet because we're going to need it, and we're going to do this example. This example that says use key equal to 4 for decimation cipher. To encode, and we'll have a couple of parts. Part A, letter I. So we'd like to encode letter I using the decimation cipher with key. Maybe I should switch it and say K equals to 4. All right. So we take letter I, we use the procedure, we look up I in the alphabet, that's number 8 in our list. So it's going to be 8 times 4 mod 26. So nothing went wrong, so we get 32 mod 26, and 32 and 26 are close. We can subtract them, right? 32 minus 26 times 1. So we're going to get 6. So we're going to get 6. And we look up position 6. That's going to be letter G. So everything is fine, right? Nothing is wrong. But let's go to example part B. Someone tells you we're going to encode letter V with this key k equals 4. So we put V, we look up the position of V. V is 21, so we take 21, which means 21 times 4 mod 26. We multiply it out, so it's 80 and 4, so it's 84 mod 26. So we take 84, we divide by 26, so we get 3.23 ... which means that it's 84 minus 26 times 3. So 84 minus 26 times 3. We get 6. So we get also G, because 6 and G. Look, what's the problem? The problem is that letter I would be coded with letter G, and letter V will be, didn't write it correctly, should say 6 and G over here. And letter V will be coded with letter G. So what's the problem? Two different letters, I and V, go into the same letter G. So that means if you would want to decode, by the way, we didn't really talk how to decode yet. That's our next idea. But for now, we have a big problem, because if you have letter G, we don't really know whether it was letter I that went into G or it was letter V that went into G. So we cannot decode. So what's the problem? The key k equals 4 is not really a good choice. Right? Not really a good choice. But the question is then, what are the good choices? Why 7 worked? Why 4 doesn't work? So we have a lot of issues. And another issue, how to decode. So we need to fix this. These issues. And again, to fix the issues in our class, we need to learn a little more of mathematics. And that's what we're going to do in the next lecture. It should be really interesting how to fix this bad thing that happened. I'll see you in the next lecture.